Hi, welcome back. It's time to introduce the concept of pipelining, which will increase the compute throughput. But we're not going to start with computers and compute tasks for now. Let's start with a real-life example, or almost real-life example. Let's suppose that Dan and Bora go back to college, and they're in the same dorm with some of your favorite TAs, Avi and Caroline. And now on, say, a Sunday night, Avi, Bora, Caroline, and Dan all need to do the laundry. In the basement of the dorm, there is a laundry room. And the laundry room has a washer, a dryer, a place to fold the laundry, and then a means to stash the laundry to take it back to our room. So the washer takes 30 minutes, the dryer takes 30 minutes, folding takes 30 minutes because it's kind of tight space in there, and then stashing takes 30 minutes because we need to walk our laundry back to our rooms. So since there is 4 of us that need to do our laundry, we have 4 tasks: A for Avi, B for Bora, C for Caroline, and D for Dan. So let's see how we could do that. So if you have a kind of a strange RA, they may decide that we have to do it sequentially, meaning that only one person can do the laundry at a time. So first would go Avi. At 6 p.m. he would start his laundry, and he would go through his 4 cycles or four phases of processing the laundry. He would first go wash it for 30 minutes, then dry it, fold it, and stash it, and we'll be done at 8. Then Bora can go at 8 and wash it, dry it, fold it, and stash it. He'll be done by 10 p.m. Then Caroline can start. She would wash it, dry it, fold it, and stash it. Will be done by midnight. And Dan would have to start at midnight and finish his 4 phases of laundry execution by 2 a.m. Is there a better way to do this? Yeah, I mean, if you look at this scenario, we had 3/4 of a time our resources were not utilized. Washer was used for 30 minutes every 2 hours. Dryer was used for 30 minutes for every 2 hours, and the folding area was utilized only for 30 minutes every 2 hours. We used the stairs for stashing our laundry only 30 minutes every 2 hours, in 2 hours. So we certainly can try to do multiples of these things concurrently, multiples of these phases of laundry concurrently. So instead of having sequential laundry that takes 8 hours for 4 loads, perhaps we can do better. So here is an approach of pipelining laundry processing. We still have 4 tasks: Avi's, Bora's, Caroline's, and Dan's. And we are still going to start at 6 p.m. But we should be able to take less time if we overlap our tasks. So Avi still has to start at 6, and he's going to go through his cycle of washing, drying, folding, and stashing. And he will be done at 8. But Bora doesn't have to wait to start at 8. Bora can just start at 6:30 and go through the 4 phases of laundry processing. Caroline can start at 7, wash, dry, fold, and stash, and then can start at 7:30 and be done by 9:30, just in time to record his next lecture. All right. So that there was a dramatic speed up that happened here. But notice what happened. Let's just make sure that we understand exactly what happened. The speed up was, instead of 8 hours, it took us 3.5 hours for 4 loads. So that's pretty good. There are still things that happen sequentially. So phases of laundry processing still happen sequentially. So each one of us took 2 hours like before. But multiple phases or multiple stages of laundry processing happen simultaneously. And in particular, take a look at what happened at 7:30. While Avi was stashing his laundry, Bora was folding his laundry, Caroline was drying her laundry, and Dan was washing his laundry, which fully utilized all the resources. But while we were starting up, the resources were not fully utilized. It took us 3 cycles to fill up the pipeline such that we had the full utilization, and then it took us 3 cycles to drain the pipeline. So if that is not obvious, at 6 p.m. only the washer was used. At 6:30 p.m. washer and dryer were used, and so on. Now, if there are 1,000 people trying to use this laundry system, it wouldn't have taken 2,000 hours. If we were to pipeline it, it would have taken 503 hours, because it would take us still 3 cycles to fill the pipeline. Then everybody would be running 4 tasks in 4 phases concurrently, and finally in the final 3 cycles we would drain the pipeline, and all 1,000 loads would be processed in roughly 500 hours. Okay, so here are some of the key points to take away about pipelining laundry processing. Pipelining doesn't help the latency of a single task, because a single task still takes 2 hours, no matter what. But it helps with the throughput of the entire workload. The entire workload got done significantly faster, in this case 2.3 times faster. There are multiple tasks that are operating simultaneously or concurrently using different resources. Now, the potential speed up equals to the number of pipe stages that can be simultaneously used. In this case, there are 4 of them, so the theoretical speed up that we can have is 4. But we did not achieve the speed up of 4, we achieved the speed up of 2.3 because we needed some time to fill the pipe and then drain the pipe. If there were 1,000 tasks that were using the same pipeline, then we would have gotten much closer to the 4x of theoretical speed up. So that's one of the key ideas. A few other takeaways here. Now, somebody decides to invest in improving the laundry system. So supposedly they get a new washer that takes 20 minutes instead of 30 minutes. And then new stashing system perhaps uses an elevator and will take 20 instead of 30 minutes. How much would that improve the whole operation of the laundry in that dorm? So it, for example, if you had 1,000 people using that laundry, would it dramatically shave it? Instead of 500 hours, would it take about 2/3 of 500 hours? No, because the throughput of this whole system is set by the slowest tasks or the slowest resources that we have in the pipeline. This would shave off 10 minutes of the beginning and 10 minutes of the end. The washer is going to take 10 minutes less, will be done in 20 minutes instead of 30, and stashing will be done in 20 minutes instead of 30. So for 4 of us, instead of 3.5 hours, it would take 3 hours and 10 minutes. But it would not change the time that it takes 1,000 people process their laundry, it would still be about 500 hours. Why is that? Because even if these tasks take 20 minutes in the beginning and the end, the time is set by the slowest resources that we have in here, which will be the washer and the folding station. That's about it. So what we're going to do in the next segment, we are going to translate this to a RISC-V pipeline. See you then.